In this activity, we look at a short case study. In this exercise, you play the role of a consulting Boomi architect. You will evaluate the case situation and suggest a monitoring approach that will ensure stable performance. The customer, a manufacturer of optical switchgear, has recently deployed a customer portal that is public-facing. Anyone with a browser can access the website, search for product information, and download detailed product specifications, which are sometimes voluminous. The customer has developed a Boomi architecture that uses two atoms, a cloud atom and a local atom, to handle the requests. The cloud atom gets product information requests through a listener call and forwards the request to the local atom. The local atom processes the request, accesses product specs from a PDF library, formats an email with attachments, and emails the requested documents to the user. The customer is concerned that usage peaks in the customer portal can cause unacceptable delays in servicing requests for product information. This is a screenshot of what the setup looks like. Notice the external atom cloud receives action from the customer portal. We'll then direct that request to the local atom, which will read from the PDF library, build the customer email, and send it off through the email server. So here I would encourage you to pause the video for a moment, read through the questions, and consider some possible solutions, and then jump back in here for a brief explanation of some of these questions. So first question, where in the architecture are there potential problems and what components may fail under load? Well, you want to consider that the public-facing portal may experience peak loads or even experience DOS attacks. And the local atom may be overloaded with processing the very large PDF documents. The second question is, why are there two atoms and could the scenario be managed with a single atom? So first, you could use a single atom which could expose a website and process the document requests. In this particular scenario, there are two atoms to provide better tools to manage the load. The next question asks which resources of the atom might limit performance or become a failure point. First, you want to consider the threads in the atom clouds. You have a limit of the number of threads that can work and they can stack up and cause slowness. Also, you want to consider the threads and memory in the local atom. You can have multiple threads running, but if you're low on memory, multiple threads won't help you very much. Next question is, what monitoring tools would be best for detecting performance problems? You would certainly want to use the Boomi platform tools to monitor the atom cloud. You can also use the Boomi API to monitor the queue size if you are using a queue, and certainly a JVM monitor to track memory consumption of your local atom. The next question asks which architecture components should be monitored. So you should definitely monitor the local atom memory, and if you're using a queue, you want to manage the queue size as well. And the last question, what refinements in the architecture would make the integration more robust? So first, it's important to note that this is actually a pretty good setup. You can certainly add a queue so the external atom passes requests via queue to the local atom, and the local then processes through that queue. You can also then limit the batch size that the local atom consumes from the queue in order to manage the flow of documents and resources of the local atom. A final consideration would be to replace the local atom with a local molecule, which provides you increased processing power and the ability to run forked executions so that if one request dies, it won't kill the whole molecule.